All right, so when we're finding the sine and cosecants, we know the sine values from last class. The cosecants are just going to be the reciprocals of those, and we're just going to operate with those, okay? Last class, even though I wasn't here on the video, it talked about how you graph undefines. How do those graph on your graph? Not open circle, but what? Asymptotes, okay? So, if I'm using that chart, which I have to erase to get down here, where did we have asymptotes? 0, pi, and 2 pi. So I start with my asymptotes. 0, pi, 2 pi. If they're at 0, pi, and 2 pi, where else are they going to be? Negative pi and negative 2 pi. What other points from our cosecant table do we have? At pi over 2, what's our y value? 1. At 3 pi over 2, what's our y value? Negative 1. Now, if you want to learn a ton of different values, you can figure out what the rest of the graph looks like. I'm just going to tell you, if that's okay with you. These are U shapes. That one's a U facing upwards because it's positive 1. This one's a U facing downwards because it's negative 1. Now, if I had to continue on to the negative side, remember that sine was an odd graph, which makes its reciprocal also an odd graph. On the left side at negative pi over 2, do you think this would be a positive U or a negative U? Negative, because it's going to flip backwards. Which makes our last one at 3 pi over 2 positive. And just like sine looks like cosine, cosecant and secant are going to look very similar. They're just going to have the U's at different places. It's going to look slightly different there. Now we're going to fill out some of the same information on the back, starting with the period of the function. Before I flip my page, because I'm going to have to erase my graph, the period of the function is how long it takes to go through all possible values of the function. So how many of those U's need to be included to go through all possible values? 2 of them, 1 positive, 1 negative, right? Because you're not getting through all values if you're missing any of those. So from here to here, in between those 2 lines, you have all possible values of that cosecant function, right? Then it starts to repeat itself, kind of like a stamp. It's just the same thing again and again and again, okay? So if between those 2 lines gives me all possible values, what's the period of the function? 2 pi, because it's from 0 to 2 pi. So on the back, that's where we're starting. And we'll flip back and forth. 2 pi. All right, so if the period is 2 pi, then if we go back and look at the graph, maximum value, because we have a U facing upwards with arrows, what does it mean the maximum value of this is? Infinity, which means the minimum value is what? Negative infinity. Some of these are trick questions, kind of like that, maximums and minimums on that one. X-intercepts. Take a look at your graph. Where does that graph, not the asymptotes, but where does a graph cross the x-axis? Never. So there are none. You can say that. Y-intercept. Where does this graph cross the y-axis? It doesn't. So there is none of those either. Now, vertical asymptotes, we're going to write using that notation that we learned last class. Where's one good vertical asymptote to start with? Positive pi. So you can start at pi. You can start at 0. You can start at any of those. It wouldn't matter if you picked a different one than someone next to you. How often do they happen before or after pi? Every pi. So I write plus or minus pi k. So you could have that. You could have 0 plus or minus pi k. You could have 2 pi plus or minus pi k, because those are all appropriate vertical asymptotes. Now, with the tangent function, since this has asymptotes, it's similar to a domain of the tangent function. Remember on these, we said the way we are going to write it is all real numbers, but we're going to leave out the vertical asymptote. So I'm going to say x does not equal what? Pi plus or minus pi k. The range on this one is very tricky, so I need you to flip back to your graphs to look at this. Typically for range, we say bottom to top. So we would say, how low does this graph go? Well, if you look at the bottom facing you, it goes all the way down to what? Negative infinity. If you look at the upwards facing you, it goes all the way up to what? Positive infinity. If I say that my range is from negative infinity to positive infinity, I'm saying it's every value in between those. Why is that not true? There's a gap there between the upwards facing you and the downwards facing you. Because of that gap, we can't write it like this. So what we're going to do for our range is we're going to show the range of the downward facing you. So the downward facing one goes from negative infinity, and where does it stop? -1 with a bracket. The upward facing one starts at what number? 1 and goes up to what? Okay. So as soon as you know that gap, you can just write it as two separate sections with the u in between. And we said just because sine is an odd function, that automatically makes cosecant odd. Okay?
Can we go over what those mean again?
Even and odd, even means literally if you folded your paper along the y-axis, it would be the same on both sides. Odd is the same diagonally, which is what you're seeing here. Directly to the right of the y-axis, there's an upwards facing one, and directly to the left, there's a downward facing one, which means it's the same diagonally.
Okay. Thank you.
You're welcome. Now, I'm going to go quickly through the next two because once you know this one, the next one kind of goes quicker even. So we said sine was the reciprocal of cosecant. So in this case, since we're doing secant, we're thinking about our cosine table. So again, going through my cosine values quickly from what we did last class. Sine started at 0. Where does cosine start at? Cosine starts at 1. All right, so from our chart, we have cosine at 0 is 1. Then we have 0, -1, 0, back to 1. To get our secant values, we said we're going to do the reciprocals of those. So the secant, when I do the reciprocal, any place I see 0, my reciprocal is what? Undefined. Reciprocal of 1 is just 1. Reciprocal of -1 is -1. Now, knowing that the secant graph looks very similar to the one we just did, take these points and try your best to draw me a graph of what that would look like on your paper. All right, so what the graph of this looks like, we said we have asymptotes at pi over 2 and 3 pi over 2. Which makes them at -pi over 2 and -3 pi over 2. At 0, the cosecant value was 1, which means right in the middle here is an upwards facing u. At pi, the value was -1, which means it's a downward facing u. What's going to happen at 2 pi then? Positive, which you can draw off the graph if you would like. I like to finish it out, so I just automatically do that. Which means at -pi, where is it going to be? -pi is going to be -1, downward facing. -2 pi will go back to positive u. Now, if we look at that, we said the period of the function is how long it takes to go through all values. In this case, I would kind of separate it into this section here because that's an upwards facing and a downwards facing u. So if it goes from -pi over 2 to +3 pi over 2, what does that make the period of the function? Okay, so -pi over 2 is going to be pi over 2 from here to here. 3 pi over 2. If we add those together, what does it give me? 4 pi over 2, which is 2 pi. Now, similarities here. Here's where we start to notice these. What was the period of the function for sine, cosine, cosecant, and secant? 2 pi for all of them. So 4 out of the 6 have a period of 2 pi. They all go in pairs. Sine and cosine go together, cosecant and secant go together, cotangent and tangent go together. So on the back, our first question is that the period of the function is 2 pi. Just like the cosecant one, what is the maximum value? Infinity. Minimum value? X-intercepts? None. Now y-intercept on this is what? 1. Vertical asymptotes, you need to pick one of them to start with. Any one is fine. I would probably pick the first positive one, which is what? Pi over 2, and how often do they happen? Every pi. Because it goes from pi over 2 to 3 pi over 2, which is adding 2 pi over 2 or 1 each time. The k essentially is just a placeholder for any number. If it just says this, that means I can add pi once and subtract pi once, but that's it. It stops there. The k means I can go out twice or 3 times or 4 times, and it keeps going and going and going. It's really a silly kind of placeholder, but if you don't have it, it just means that you can't go out more than once. So then the domain on this, for anything that have asymptotes, we say all real numbers, but we leave out the asymptotes. So I'm going to say x does not equal what? Pi over 2 plus or minus pi k. Range is exactly the same as the last one. So remember, we do the range of the downwards facing u, which goes from where? Negative infinity to negative 1. The upwards facing u picks up at and goes to infinity. And then just like cosine, secant would be even or odd if you look at the y-axis. Even, because I could fold that along the y-axis and have the same piece match on either side. Our last one will be cotangent with this, and then we're going to briefly talk about transformations. Cotangent goes with tangent, so real quick, our table for tangent. We did tangent, and we'll do cotangent. The table for cotangent started at negative pi over 4, or negative pi over 2, excuse me. And for tangent, it started as undefined, negative 1, 0, 1, undefined. So if I was to do the reciprocals of that, what's the reciprocal of undefined? 0. Reciprocal of negative 1? Reciprocal of 0? Reciprocal of 1? And then reciprocal of undefined? All right, so if I graph what I know for cotangent, we're not going to graph both tangent and cotangent. We're just going to graph the cotangent because we don't have enough time to do all of this. So for cotangent, my first point is negative pi over 2, 0. So that goes right there. Where did we say pi over 4s go? Because they're not marked on this graph. They're 1.5 blocks on either side of this, so you can mark them if you want. In our table, we have the cotangent at negative pi over 4 is what? Negative 1. At 0, what do we have? An asymptote. At pi over 4, we have 1. And at pi over 2, we have 0. We currently don't have a great picture of what this looks like. However, what we do know is that this looks very similar to the tangent graph. So let's recall the tangent graph from last class. What did that look like? It had asymptotes and it was the S shape, okay? This is the same exact graph, only backwards. So let's just take a couple educated guesses. If we have an asymptote at 0, where do you think the next one is? Pi. Good. They always go by pi's. So if they're on 0, they go to pi and then 2 pi. If they're on pi over 2, then they go to 3 pi over 2. So where else would I have asymptotes here? Negative pi, positive 2 pi, negative 2 pi. So I always split it up with the asymptotes first. And then if you remember the tangent graph, we had S shapes where we had positive 1, 0, negative 1. But it was going the opposite way. So if I had to finish out that section right there, what point do you think I could add in that section? I'm missing, I have a positive 1, I have a 0. What am I missing? A negative 1. So over here to the right, I'm going to make this my negative 1. So if you compare this to the tangent graph, the S shapes are now going the opposite direction from your tangent graph. They go from the left down to the right instead of the opposite way. So I can fill in each of these sections with 0 in the middle, positive 1 to the left, negative 1 to the right. So I go 1.5 blocks out to the left, 1.5 blocks out to the right, and do positive 1, negative 1. Fill in my graph here the whole way out. Now on every graph, the worst part of it is finding the period of the graph, which is how long it takes to see all values that you can possibly see. In the secant and the cosecant, we needed to include 2 sections of it because there was one positive U and one negative U. Are each section of this graph different, or are they the same? They're all the same, which means you can see a full picture of the cotangent graph in one section here, which means if I want to state the period of the graph, I know that it can be seen in one section here, which means the period of this graph would be what? Pi. Okay? Just like the tangent graph. So these, a lot of the same things are going to be similar with these again. So if I flip to the back, the first thing we're going to fill in is the period of the graph. So the period of cotangent is pi. Max value, how high does this go? Infinity, how low? Negative infinity. These do have x-intercepts. Remember how we write those as we pick 1 and then we write plus or minus however often they occur. Where is the first good x-intercept for this? Pi over 2. And then they occur every how often? Every pi. If they happen at pi over 2 and the next one is at 3 pi over 2, that's pi apart. Y-intercept? None, because there is an asymptote on the y-axis.
Wait, so for the x-intercepts, did you have started with like negative pi over 2?
I don't care which one you start with. Pick any one on the graph. I'll be happy if you get that notation with anyone on the graph, yes. So, grading these quizzes is a little bit harder for me because I have to like check for all the, did they do this? Did they do this? Vertical asymptotes, we pick one of the first ones that we see. Where's a good one for that? 0 or pi or whatever you want to pick. Plus or minus, how often do they happen? Pi k. And domain for this, just like the other ones, any one of the ones that have asymptotes, which is 4 of them, we have to say all real numbers, but we leave out the asymptotes. So I say x does not equal 0 plus or minus pi k. Range for this one, any one of those S shapes, bottom to top, what is it? Negative infinity, positive infinity are all real numbers. And then these all go together in pairs. Sine was odd, which makes its reciprocal odd. Cosine was even, which makes its reciprocal even. Tangent was what? Odd, which makes cotangent what? Odd. Because this one, if you did fold it, it would make that S shape backwards, so it wouldn't actually work out for you. Now, the one other thing we're going to talk about today is transformations. The good thing about transformations is that we are only going to do them to sine and cosine graphs. That's it. Okay? It's not going to take us super long, and the homework, the reason I combine is because there's literally like no homework I can even give you over these three other than, here, graph them again. You know, so the day we do a couple different things. If you would, flip over till you find this page. This should actually go pretty quickly, and it will help you with your sine and cosine tables. Just for your own clarity and peace of mind, this will not be on the quiz. The quiz is just the parent functions. This is page 111. We've done transformations before. Transformations we did on tables back in the fall, and they work exactly the same way. Remember I told you if we learned the process of finding that and doing the tables where we multiplied the x's by this, added and subtracted this from the y's, it made it easier for trig functions. So here we are. And this is what we're doing, okay? So we're going to split this into 2 days. We're going to start transformations today and finish them out next class. So for today, we are just going to be doing multiplication. A couple things. If you see an A value out front here of either a sine or a cosine, that's a vertical stretch or shrink, which means you're going to multiply the y values by that A value. Inside, after the cosine and after the sine, you can see a B value. The B value is what we call our horizontal shrink or stretch, and you divide your x values by B. Now, both of these have a use in figuring something out about the about our trig function. The A is called the amplitude of the function. But one thing to notice, it doesn't just say A. What does it say? What do those bars mean? Or on the outside? The absolute value. In other words, amplitude is always positive. We're going to use the A value itself to multiply the y's. Whether it's positive or negative, we'll use whatever the A value is. But when you tell me the amplitude, it is always positive. The B value is used to find the period of the function. You are always going to take the normal period of the sine and cosine function, which is 2 pi, and you are going to divide it by B. So on question 1 here, we're just going to practice this. First, I'm not using their tables at all because I find them very confusing, and I'm going to get rid of those at some point in my life, but never have a chance. Okay, first thing I notice on this is sine or cosine? Sine. All right, so let's review our sine values. We know sine values for 0, pi over 2, pi, 3 pi over 2, and 2 pi. Easiest way to remember our sine values is to remember sine starts at what? 0, then goes 1, 0, negative 1, 0. It goes in a rotation. Positive, back to 0, negative, back to 0.
So if you have the first 2 values, then you just repeat it.
Then there's just reflections. I memorized those 5 values, both for the parent function quiz and then for the transformations, because you need to know these for transformations. If I look at my equation here to the left, I have an A value and I have a B value. What is my A? 3. That makes my amplitude what? 3. The amplitude is just the height of the wave. 3 up, 3 down. In the paragraph we just talked about up here with the formulas and stuff, we said we're going to take that A value and multiply it by what? The x's or the y's? Multiply the y's by A. All right? So I'm going to go through this table, and I'm going to take my y values, and I'm going to multiply each of them by 3. Easy enough? All right. Now, what's my b value in this formula? 2. Here's the weirdest part about this. Everyone wants to make that the period. That is not the period. You use it to find the period. So the period of the function is 2 pi divided by b. If I divide 2 pi by 2, what do I get? Pi. We also use the b value to divide each of the x values by b. Now, when we're dividing fractions, what does that mean? The same as what? Multiplying by the reciprocal, which in this case is what? What's the reciprocal of 2? 1/2. So I literally in this table do this by each of these. So that I can work through each of these multiplying by 1/2. What's 0 times 1/2? 0. What's pi over 2 times 1/2? Pi over 4. Good. What's pi times 1/2? Pi over 2. What is 3 pi over 2 times 1/2? 3 pi over 4. And what is 2 pi times 1/2? Pi. Okay, once you do that, we've taken care of our A, we've taken care of our B. There are new points. So what's my first point that I'm going to graph? 0, 0. Okay, I'm going to have to erase these because I didn't scroll down to see my graph. I'll give you a second to look at these and then I'm moving. The last ones are 3 pi over 4 and pi. All right, so down here at the bottom, first point we said we had was 0, 0. Where's the second point? Pi over 4 up 3. Where's pi over 4 again? 1.5 blocks over, right there. Up 3 will be here. Third point we had was what? Pi over 2, 0. After that, we had what? 3 pi over 4, negative 3. Now, if I don't know where 3 pi over 4 is, it's one of the over 4 ones, which means it's halfway between any two sets here. I would probably guess it's 1.5 blocks over right here. Okay? Everything has to be evenly spaced. That's how these points work. So that kind of works to our favor. So then that's negative 3. And then we go back to where? Pi. Now we're going to use the same pattern to graph this out, the full graph. Each of these points are how far apart? 1.5 blocks, right? So next after pi, I'm going to go over 1.5 blocks and where? Up 3. I'm going to go over 1.5 blocks back to 0. Over 1.5 blocks down to negative 3. Over 1.5 blocks back to 0. And if I go backwards from 0, I'm going to go over 1.5 blocks and where? Down 3. Over 1.5 blocks back to 0. Over 1.5 blocks, now which way? Up 3. So literally you're just using this pattern. I just start using how far apart are these points, as you can see by me saying the 1.5 blocks thing a million times. And I graph my points backwards to 2 pi, forwards to 2 pi. Whoop. Ew. I hate when I can't connect them right. Do any of the things that we've done to this graph change my domain? All sine and cosine graphs have a domain of what? Negative infinity to infinity, or all real numbers. Range is lowest to highest. So what's that in this case? Negative 3 up to 3. So that's going to change based off the amplitude. But you can read those off the graph. Okay. We're just going to practice this again 1 or 2 more times, but we're not adding anything more to it. Okay? Mainly it's just the idea of doing those tables that we have to practice with real quick. I'm not giving you a ton of homework on this either, so don't worry. 8 problems total, all homework. Okay? All right, so I'm going to do 2 with you. You're going to try 3 on your own, and then we'll finish up with 4. First, in question 2, what graph are we given here? Or what equation? Cosine. So first, we just have to write down our cosine table. Remember, our x values are always the same for each of these, because we do the same 0, pi over 2, pi, 3 pi over 2, and 2 pi for all of them. Cosine starts at what? 0 or 1? 1, then goes to 0, then -1, back to, then 1. All right. So once we have our cosine, then we use our points or our letters out of our table. What's my a value for this? -2. That means I'm going to take -2 and I'm going to multiply it by my x's or my y's. By my y's. So I'm going to go through each of my y's here and I'm going to multiply them by -2. The only tricky part about this one is that even though we multiply by -2 here, what is the amplitude? +2. What is my b value? 3. To find the period, I take my b value and do what? 2 pi divided by b. Can I reduce that? 2 pi over 3? Nope. So that is the period of the function. What else do I do with that b value? Take each of my x's and do what? Divide by 3, which is the same as multiplying by what? 1/3. So again, write this out for yourself. 1/3 times each of these. Unless you're really good at fractions and don't need to do that. Totally up to you. When I multiply each of these by 1/3, that gives me, what's 1/3 times 0? 0. 1/3 times pi over 2. Pi over 6. 1/3 times pi. Pi over 3. Now, when you do 1/3 times 3 pi over 2, the 3's cancel, which just gives me what? Pi over 2. And then 1/3 times 2 pi. All right. Now this one, I'm going to help you graph. When we start off, the first point's easy, 0, -2. So here's my 0, -2. Where is pi over 6 on these graphs? Do you remember from, it's the first one. So if the second point in the table is the first line over. So there's pi over 6, 0. Where would you guess pi over 3 is? 1 more over from that. Everything has to be evenly spaced. So even if you don't know where these are, if the first one is 1 block over, then the second one's 1 block over from that. That's just how it goes. So pi over 3 is the next one, up to. That works out for us because the fourth point is where? Pi over 2, 0. And then again, if I don't know where 2 pi over 3 is, well, everything's been 1 block apart, so I'm just going to keep working with that. 1 block over, down 2. Can you use that to fill the rest of your graph then? Everything's over 1 block and up and down the same amount of values, up to 2, down 2, so on. So you can use this to fill the rest of your points in. I'm just going up 2, down 2, the whole way out to 2 pi and -2 pi. Remembering that these always go in the up-down wave format. And connecting my dots with a nice, smooth cosine curve. Please do not make these zigzags. I don't know why that annoys me. It makes me feel like you haven't paid attention the whole time. About right. So that is what that one looks like then. Issues with that? All right, I'd like you to practice the next one on your own paper. It's a sine graph to start with. So try at your tables to work with each other and do number 3. All right, so the only reason I do question 4 is because of the b value here. We've gotten quite a bit of practice on this, but the b value on this one's a little bit different. I'm going to scroll down here. We have enough room to use tables down here. In this case, it's a cosine graph. So I'm going to start off with my cosine points. And you can start seeing now why I said it was best to just memorize these tables, because we repeatedly use them. In this case, what's our a value? -3, which means I take my y values and I multiply each of them by -3. That means my amplitude is what? +3. So you can fill that in up here. What's our b value on this? Pi/4. If I am going to find the period of my function, I'm going to take 2 pi and divide by pi/4, which is the same thing as doing what? Multiplying by 4/pi. What happens when I flip that and multiply? The pi's cancel, and what does that make the period of the function? 8. All right? So the period of the function is 8 in this case, which should make sense according to the labels, because if you look at the labels on the graph, are there any pi's in them? Nope. All right, so that also means that when I go through my table here, I'm going to flip and multiply there, which means I'm going through my table and I'm multiplying each of these by 4/pi. It's going to work out a little bit nicer than you think right now. First and foremost, what's going to happen on all 5 of these with your pi's? They're going to cancel. So just start off by canceling pi's. The first one's easy, it's 0. The second one, the pi's cancel, and it's going to give me what? 2. The third one, pi's cancel, gives me 4. Are you starting to see a pattern? 0, 2, 4, 6, 8. There you go. So my points on this one are 0, -3, 2, 0, 4, +3, 6, back to 0. I don't have 8, but I can follow the pattern backwards here. If I went to the left, I'd go -2 back to 0, -4 up to 3, -6 back to 0. What would be my domain for the whole thing of this? Or all real numbers. Range? Two. Okay, good.